Hello everybody and welcome back to the Quantum Classroom and to our Careers in Chemistry series where we're doing interviews with leading researchers across all fields of chemical sciences, trying to show you what working in the chemistry industry is really like.
We're delighted to be joined by Associate Professor in the Chemical Science Department of UL, Dr Shalini Singh.
Thank you very much for joining us.
Thank you so much for inviting me. I'm actually looking forward to talk to you guys.
That's good.
I suppose the first thing we do is we get you to introduce yourself. Tell us a little bit about yourself and your work.
Okay, so hello everyone, whoever is listening. So my name is Shalini Singh. People call me Shalini here most of the time. So I'm an associate professor in Department of Chemical Sciences, and I teach a lot of undergraduate classes. And my research is actually focused on making functional nanomaterials of sustainable composition to actually replace everything toxic we have in the ongoing technology with new compositions that are something that you can actually breathe around. And we do it by different kind of chemistries in our lab. And we look into specifically in energy application like batteries or electrocatalysis, where we are reducing carbon dioxide or generating hydrogen for energy, and thermoelectric devices, and all that sort of energy conversion and storage applications.
Yeah, so as you said, you're researching into nanomaterials. What's the importance of that research in your opinion, and what kind of impact do you think it can have if it's successful?
So nanomaterials at the point, right? Like you have seen every second advertisement on your TV is about using nano. Nano is there in cosmetics, nano is there in your photovoltaics, nano is there in your batteries, nano is there in your phone, iPad, everywhere, right? And and everything nano that we have, specifically in the technologies like batteries or quantum dot TVs, right? Most of the things are made up of elements which are either toxic or carcinogenic, or are really rare earth metal that will actually start depleting as soon as possible. And the thing is that because they're easy to make, like it's just like, if there is something really bad in composition, it actually works really nice.
Yeah.
So what exactly happens is like cadmium cyanide is one of the best quantum dots ever, but cadmium is carcinogenic.
Yes.
So the thing is that everything that is toxic works really good. So what we're trying to do is to look into something that is sustainable, like sodium or copper or bismuth, or something that you can actually think about if that thing gets in contact with your own children, right?
Yeah.
Are they actually exposed to toxic compositions? So that's what I'm trying to do, is to actually create sustainable material. But most of these compositions are not exactly experimentally synthesized.
Right.
Or they have a phase diagram where you are just having three different elements together joining. But they will make variety of different compounds with different properties. So how to control them at the very molecular level so that you get what you want.
Yeah.
So for that, you need to really look into the chemistry of how to actually design them. So that's what we are doing at the moment in our lab, that we look into the computational prediction of all the different materials that can be synthesized, or they actually have a scope of being like really high absorption coefficient, so we can use it in PV devices.
Yeah.
Or really nice electrochemical activities that we can actually use it for carbon dioxide reduction into something really useful. And then to design those material and to tailor their property according to what application we are putting in.
Okay.
So if everything goes well, I'll leave a sustainable future for my son.
That would be good. And then what kind of, like those sustainable materials, what kind of things can you do with them, or would you like them to be able to do?
So, for example, just at the moment in our lab, one PhD student is working on making sodium copper sulfide.
Right.
Right now, it's technically now kind of a nice, amazing universe. It might be, you can actually eat it. Sodium and copper and sulfur, right? They're technically edible things. Like sodium, you have it in your body. Copper, technically good for most of the things that most of the different signals that are transmitted in your body. Sulfur is technically, again, amazing. So in my opinion, it's a very non-toxic, very happy material, right?
Yeah.
Experimentally, it has never been made. So we are making it now. And the PhD student actually is able to design like 3 different kind of phases of it.
Right.
One of them is really good and it has metallic character. So if everything goes well, will be really nice for example, battery, the sodium, potassium, and battery compositions, where sustainable battery, they
Yeah.
need earth-abundant electrodes. So that's where it can go. Another composition is very semiconducting in nature. So that can be very good for photovoltaic devices. And it
Okay.
has a very light carrier. So the charge carriers in those, whenever the light hits your material, the material will actually have carriers that
Yeah.
will carry the charge, transport it through, generate the electricity and all those processes. So all these charge carriers that are there in sodium copper sulfide are very lightweight, so very easy for their transport and mobility. So those are the things that we are tuning, that each different stoichiometry of sodium copper sulfide will
Yeah.
have different properties.
Okay.
And yeah, and just like that, there are many other different materials that we are investigating and working on. So we are trying to create a platform where just by using a simple chemistry, you can actually produce at least, like in my own prediction, 65 different kind of compounds.
Oh, wow.
So it would be easy to just, so we are trying to create kind of like a scientific platform
Yeah.
for new material formation and design and tailoring of their properties.
That's really cool.
Yeah.
If everything goes well.
Fingers crossed.
As many of the students listening will know, or any of our listeners will know, I love organic chemistry, and it comes under a massive part of the Leaving Cert chemistry course. So like I suppose, what we're asking is like, how important do you think it is in industry, in kind of research?
Look, I'll tell you in all honesty, right? Up to the age of 16, I didn't want to do organic chemistry.
Okay.
I was a big fan of genetic engineering. That's all I ever dreamed about to do. Like, that's the whole idea, that I will go for genetic engineering. Well, I'm from India, and in the state there and the city that I was in, we didn't had nice biotechnology courses. So my whole idea was to finish the degree from here and go and study and do a master's in biotechnology, and I'll be happy, and then I will create genetically modified human and life will be amazing.
Yeah.
That's the entire thing. Like, my bedtime storybook was Leninger biochemistry.
Wow.
I would read like 15 pages of it every night. I was so mad about it. But then my dad passed away just before I can transition to biochemistry or to leave the city. So leaving my mom and my two siblings, younger siblings, didn't really seem like a good option. So
Yeah.
I stayed there. And in my city, the only good thing that was there in our college was chemistry.
Okay.
And then with all the sadness in my life, I took chemistry. And I had this organic chemistry teacher. And there was a saying about him that he holds time in his class.
Right.
So it's all about him and the blackboard and the chalk in his hand and the proton and the electron moving around the table and creating a new product. And just because the way he spoke about chemistry, just the way he drew the whole thing, just was so mesmerizing that I started looking into organic chemistry and going to the library, and I'll learn about this one acyl substitution reaction. And then I'll go in the library, look into the book, take a new product and try to create the reaction mechanism on my own. I started getting into, my God, this is so good. Like, I do have the proper, you're then the director of your film, because you can actually direct the entire story, how your product will be created.
Yeah.
And that's how I started loving organic chemistry so much. And then as you go up and up, I did a project during my master's, or after my master's actually, on creating polymeric membranes for water desalination. And there were companies who were investing into making this purified water for, people who are living in slum areas and these things. And that was like, this is so cool, right? This is something you're actually rescuing the world by your small little chemistry you're doing.
Yeah.
And then as I see it over here, and when I give organic chemistry lectures, and I have friends who work in different companies across Ireland, and sometimes they call me asking about double distillation of this product and that, because they're not chemists or organic chemistry, but they're actually working in making a new pharmaceutical compound, which needs organic chemistry. So it actually is blended in making different polymers. So all the adhesive companies, all the paint companies, the dyes, then the pharmaceutical drugs.
Yeah.
It's technically everywhere. So if you're studying organic chemistry, and I hope you are, please do, because it is really essential, even to actually identify a proper protein structure. If you're so much into biology, which most of the people here are, you need a proper idea of organic chemistry,
Yeah.
right? So definitely, like, I think it's the essence of life. Wherever there is
Yeah.
life, there is organic chemistry.
Okay.
Yeah.
So you kind of like, and do you think there are any kind of misconceptions about organic chemistry that people automatically hear it go, oh, such and such? Do you know what I mean?
No, there's one thing I always
Yeah.
learn from my own students, right? That it's
Yeah.
all about memorizing.
Yeah.
But it's actually not. If you know the concept of how a reaction mechanism will work,
Yeah.
it's nothing that you have to memorize at all. You just know that the electron will be attacked by this particular group.
Yeah.
And then this is where the electron will move, because that is where it is needed. And it's not that you have to memorize any of it once you know the concept. So you definitely need to attend the lectures and then look back into the books. It's nothing to do with memorizing. The only thing that you have to memorize is myth, ith, probe,
Yes.
and text, and that's it. And after that, it's all about getting the concept clear, and it's easy then.
Yeah.
I mean, I won't say like easy, because learning is not meant to be easy.
Yeah.
It's
Exactly.
meant to be hard. That's why it's learning.
Yeah.
But still, it makes your life easier if you actually think about the fact that you need to know the concept rather than to actually memorize everything written on your notebook.
Yeah. It's a far better way of learning nearly.
Yes.
Yeah. Okay, and you kind of touched on it a bit, right? But what has your kind of journey been so far, academically speaking, personally speaking, whichever?
If I have to look myself as woman in science, right, I have been way luckier than many women in science that I have known. The women who have started, or the professors who have started 10 years before me, or the professors who have started 20 years before me, I've been way better in position than them, because, to be honest, they build the way for new women in science, because it's hard to, be a woman in STEM. You go through a lot of things and everything. So my journey has been so far good. And of course, there are many failures in between. There are many times that I feel like I'm not good for this job. Imposter syndrome just goes like, when you're a master's student, you're an imposter syndrome carrying student. And then it becomes imposter syndrome carrying PhD candidate. And then it becomes imposter syndrome carrying professor. It never goes away. Like, you always think you're not good for this.
Yeah.
But then there are times that, you need to look back into the things that you have done and it actually worked.
Yeah.
And then come back to it, because my husband always does this, that he collects he asked me to collect, like, all the students' reply and the SET comments that I have. And my God, some students are so amazing. And they give me such nice emails about like how much they were inspired or being amazed. And I collect them in my album, in my phone. And there's an album called The Students' Love Letters. And any time there's a proposal rejection and I feel really low, I go back to that. And I look forward and I was like, no, life is good. Life is good.
Yeah, that's good.
So it's not bad. And of course, like everything takes a while, to happen. And you have to work really hard. And there have been times that my son was 4 weeks old and I will feed him in the morning, 4 o'clock. And then I will go to my office and start working on a proposal because there's a deadline. Even though I was on maternity leave until 6, and then go back again, feed him. So it has, like, I used to have like group meetings on Saturday when my husband can actually take care of my son and I can actually go and mind my students. So it's always a struggle, right? But I still think I'm in a very good position compared to a lot of people around the world. So it's good.
So like, if you could go back then, if you could rewind and go right back to the beginning, would you do anything differently?
I wouldn't doubt myself a lot, though.
Yeah.
It takes a lot of time and confidence away from you. So that's one thing that, you always doubt yourself. And I was like, no, I can't do this. I can't do this. So that shivering and that crying before doing something has been so much in my life. So it's like, if I can remove that much, then I would actually focus more on the things that, were of
Yes.
importance
Yeah.
rather than investing 30% of my time and just self-doubting.
Yeah.
So yeah,
Yeah.
that's one thing that I would love to remove, although I'm getting better at it.
Yeah.
But yeah, still it takes a while.
Okay.
So your research, as you said, is based on mostly on nanomaterials.
Mhm.
What was it that led you to nanomaterials? Like, what got you interested in that kind of area of chemistry?
So when I was looking for PhD positions, right, after finishing the master's, so then there was this whole idea of making polymer membranes and nanocomposite polymer membranes. So
Yeah.
you add an element in there, and that changes the functionalization of the membrane. So I was like, okay, this is nanocomposite. But then when I was looking for PhD positions, this position was here in UL, and and at the bottom of the whole PhD position opening, it was written that the candidate will be trained on transmission electron microscope. And I was like, yeah, I'm applying.
Yeah.
And still, like, if I get a nice TM picture of the nanocrystal, it makes my day.
Yeah.
Yeah.
Like, I have really nice nanocrystal pictures in my home office and like mixed type frames
Yeah.
of it, because they're just so beautiful.
Yeah.
Yeah.
And if you take the picture yourself, oh my God, like you're the best photographer of the world then. So that actually was technically the driving force of applying for this PhD. And still, like, very late evenings in the TM and MSSI and Bernal has been my biggest motivation of all time to do nano.
Yeah.
And then
Yeah.
as you grow and grow in science, and then you look into the sustainability aspect of it, the circular economy of it, how you can actually rescue the world with this really tiny compounds and really tiny crystals. And then it just keeps motivating you over and
Yeah.
over again. And then you keep doing it. So yeah, it's just the TM picture. I think the TM was one of the driving things
That's
for
what actually
nano.
What's been the most surprising discovery you've made so far? Or one of them?
For me,
Yeah.
so there was this, actually it's on a very toxic compound,
Okay.
cadmium selenide, but we were actually making, so cadmium selenide can actually have atomic layers of cadmium, selenium,
Right.
and you can make it in like 3-4 monolayer of atomic layers.
Okay.
And I wanted to look into what was there in that inorganic nanocrystals were passivated with organic ligands, right? But what exactly happened when your nanocrystal is this thin and there are millions of them together with ligands attached to their flat surface? They kind of join like this, and then all of them start stacking. And it was just so hard to get one individual nanocrystal out of the system,
Yeah.
so that I can actually look into what exactly is the surface chemistry of them. How many ligands are there per nanometer square? And one late evening, with all the frustration, I just injected a ligand that I didn't really like to inject. And it worked.
Oh, wow.
All of them just separated because cadmium oleate that we used for those things actually healed the surface and was so dense and bulky that they all just separated down.
Yeah.
And I was able to really identify every ligand that was there on the composition. And we actually ended up collaborating with other physicists, and actually that one little study was then expanded into looking into what their exciton dynamics is, what's the physics of it and everything, because now we have stable one crystal on its own.
Yeah.
So we can actually do a lot of science. And it led to like 9-10 research articles just in that one late evening frustrated molecule injection. So yeah, that so far was my most surprising discovery that I should have done it before.
What's the process? Like, how do you go about synthesizing something like a new material? Like, how do you do that?
So at this point, how we do is like we are into like ternary composition of metal chalcogenides, where we can actually use sustainable metal.
Yeah.
And as chalcogens, which are sulfur, selenium, tellurium. So sulfur or selenium, because they're happy elements and actually really nice to work with because their property can be tailored really nicely. So we look into the computational prediction of how the combination of 3 different metals will actually impact. We have computational chemists as collaborators in UK and Spain, and they come up with this very amazing prediction of, oh, this particular composition will be the next photovoltaic ink of all time.
Yeah.
And then we look into how was the formation energy of it. Is it feasible to make?
Yeah.
And if these three elements are combining, what stoichiometries they can combine? Will they have a crystal phase that is actually easy to synthesize? And all these things. So these are the work that you do before thinking about working with it. And then at this point in our lab, because I have some really nice dedicated PhD student, they have created like libraries of precursors you can use for each element. And how they can actually be combined so that the reactivity potential can actually match. Because you're combining 3 different precursors, right?
Yeah.
Or 4, or sometimes we are also creating some of them which has 6 or 7 elements together.
Yeah.
So how will they all mix up so that all of them can fuse together to make one element or one crystal?
Yeah.
So that itself is a bit of a chemistry work to go in and a reaction mechanism. And with all that studies together, we start our first batch and make the first crystal. Did it work? If not, was there a byproduct? What is the byproduct? Which means that there's a reaction potential difference in one of those metals that are creating, that is hyperreactive and making a byproduct. How to settle it down. So then we work on the chemistry of the precursors and then work on temperature on which that is growing. And in total, in a while, then you actually create the set of the material that you're interested in.
Yeah. What's the biggest kind of challenge of that whole synthesis process?
So the whole thing is like, you know, the way, like, again, I teach organic chemistry, but my research is in organic chemistry.
Yeah.
Right. So in organic chemistry, what led me to do organic chemistry was always that I was the director of this film. So I can actually write the reaction mechanism that this product will can actually use to be formed, right?
Yeah.
In inorganic chemistry, we don't have these kind of systems. And specifically in semiconductor nanocrystal making, we usually have relied on like hit and trial. Just use 2 precursor on a particular temperature and boom, something happened. And we made the crystal. And it's very like burst nucleation of nanocrystal happens and then the growth and you get nanocrystals out. But what I'm trying to now do is to actually create a synthetic lever inside this whole chemistry so that I can tune the entire chemistry of it. So we start with like, what will be the, when you actually make it, what will be the intermediate phase that is forming? So I'm trying to control that intermediate phase so that if I know the intermediate phase can be stabilized in this way, so I'll choose a precursor related to how to control that intermediate phase. And then once I have a controlled intermediate phase, then how to tune the rest of it to actually control the final phase. So that's how I can actually then visualize maybe in a couple of years' time to create a universal platform to make different material by just tuning that one intermediate phase that will form in between. So that's how we're doing it now.
Cool. I remember reading, I think it was on your website, that it says it was nanomaterial synthesis from a top-down approach and a bottom-up approach. What's the difference between those 2 things and those 2 approaches?
So if, for example, if you're trying to create a sculpture from stone and carve it, right? So you have a big blob of this big stone, and then you create a really nice statue out of that. So that is a top-down approach. You started with a log, and you created a material by just breaking it down and creating it, right? And now try to create the sculpture out of Lego. Right? So now you have this teeny tiny bricks and then creating the entire statue of it. So that's the bottom-up approach. You started with the really small building block and created the entire building that you were interested in. So that's just a normal phenomenon of how top-down and bottom-up approach works. So for example, if I'm interested in making this nanocrystal, right, of a particular composition, there might be bulk material of it. So what I'm trying to do is to just use the bulk material and just break it down into tiniest processed crystals. And if this teeny tiny processed crystals are actually micro or nanocrystals. So that's my top-down approach. And now if I'm starting with a molecular precursor, I can
Yeah.
build them atom by atom. In a way I can do it.
Yeah.
And that's my bottom-up approach.
And then how do you decide which one you're going to use for a particular task?
So there are experts on both of these fields, right?
Yeah.
Basically,
Yeah.
if I have to do it myself, like if I know some of the bulk material, like for example, molybdenum sulfide or tungsten sulfide, right? They have bulk powders and you can just sonicate the powder in a nice, really nice solvent. And they exfoliate layers and layers, atomic layers of these material out.
Yeah.
So that's top-down approach. And for me, it's easy to do it, but I'm not an expert on top-down, so I wouldn't assume to do it for every composition.
Yeah.
Yeah.
But I know the chemistry of it.
Yeah.
I know how to join atoms together. So I will always go for bottom-up approach for literally everything I have
Yeah.
to make. So more of a chef rather than actually a decorator.
Yeah.
So yeah. I mean, nothing harmful of like, I really like the top-down approach people. It's just that I don't know myself how to do it properly. So I always go by the other side.
Yeah. So, okay, so obviously you're from India originally, right?
Mhm.
What led you to Ireland? Like, what's the experience been of working away from India been like?
It's mixed, right? Because if you have to leave your country, you're leaving your family, your friends, your home, and it takes a while to settle somewhere.
Yeah.
And I came here to do my PhD, and I loved it because I was in a very Irish group, actually. I think I was at the time the second Indian of the entire group, and the first one left. So, and somehow I was just taken in as their own
Yeah.
kind of thing. So it never felt like I don't belong here. So I used to call it like my research family. And it was just, I really made nice friends. I used to live with a German and a Brazilian and loved it. We had really nice chemistry in our housemates, and they're still one of my best friends. So we had I made really nice friends here. And then I moved from here to Belgium.
Yeah.
And they used to come and visit me, because
Oh,
Shannon Airport,
Yeah.
or Dublin, and $9.99 is the Ryanair ticket,
Yeah.
so it's easy to come and visit me. So they used to come and visit me. Sometimes I'll get the visa and I'll come to Ireland as well.
Yeah.
So we always had the connection. So when the job came in, I was actually targeting to go to an English-speaking country, because if I'm away from home, I need to be actually integrated in the society in a way that I can actually understand the language. So I was, and my husband that time, we had a long distance relationship. He was in London. So I was targeting more on UK.
Yeah.
And then the job came here and they were hiring, and I applied and I got the position. And at that time, I was also in the final round of interviews in UK in a university. And then it was just like coming back home, because I already know the system. I have friends here. So I was like, who is going to wait for the next round? Let's just go over here.
Yeah.
And came here. I stayed with my friends for the first 3-4 weeks until I found my own apartment. So then it's just so easy to transition, and that they bought my SIM card. Gomo Mobile was €10 that time. Amazing offer. So, and then it just helped settling in.
Yeah.
And even specifically because I started and COVID happened. So then was not able to leave the country, was not able to do anything. So just having friends here that time was really good, because I cannot imagine how I would feel if I'm in a new country and suddenly COVID happens and you're not allowed to go more than 2 kilometers.
Yeah.
Right.
You're by yourself.
Yeah, and you're by yourself. It's mad. It's really depressing.
Yeah.
So I'm happy in that way. I wasn't, my mental health stayed strong because I had friends.
Yeah. And okay, and so what kind of professional adjustments did you have to make from studying in Belgium even and then moving to Ireland? Is there any major differences in how you have to?
So again, there I was, so I did my PhD here, and there was a postdoctoral scientist experience that I had there.
Yeah.
And then here, now I'm a professor.
Yeah.
And all these jobs have different requirements.
Yeah.
Right. And different end goal that we are trying to achieve. So one thing that was really difficult to start with was my very first class was 300 students.
Oh, wow.
And it was intense. I was so afraid of teaching. But the minute I started the class and started liking it,
Yeah.
and then in like, one or two lectures, and I was like, oh no, it's actually cool. Like
Yeah.
I am enjoying it. And teaching is technically 40% of my job, right?
Yeah.
So, and research is 20% is the leadership and academic. And research was always that I was really inclined into, because my postdoctoral experience was all about research.
Yeah.
Different projects, and it was intense in research. So then I was like, oh, this is good, because in research, like, not every day is a nice spring day, or,
Yeah.
it fails most of the time. Sometimes it is a happy day. But in teaching, it was always a happy day. You always go to a class, you teach, and you inspire people, and they're happy, and you're happy.
Yeah.
So it was like, so that became my safe space in this whole drama of being a new tenure track lecturer or a tenure track professor. Teaching became like the happy times of mine, and still is. So that was the adjustment that I found, that, oh, this is actually for good, because, it actually relieves you from so much pressure if you're actually having a nice time teaching.
Yeah.
So that's why I like now.
Okay. And so, kind of getting a bit philosophical here, but what does the future look like for you now? Where do you want to go?
I want to stay.
Yeah.
Never going back.
No, I like what I do, right? So Monday morning, I'm really happy to come to work.
Yeah.
So that's something that I enjoy, and I hope I keep enjoying coming to work every Monday morning. And Friday evening, I love going back home to spend the 2 days with my family.
Yeah.
Right. So it's something that I would like to do until retirement. Definitely with research. Hopefully one day the sustainable future will be there, so that I can rescue the world in whatever way. Like, you always want to, with your science, do something and change the world.
Yeah.
So even if my science can contribute to a little bit of change, I would actually be happy when I will look back to my career. And teaching, I really want to bring it. Like, chemistry is something that it's very few people take chemistry here in Livingston. And if in this whole scenario and all these podcasts that you guys are doing and everything, if that can change the concept and people are less afraid of chemistry, oh, trust me, that will make my life so much happier as a professor that I can't even tell you. So
Yeah. And so are there any kind of, in the near future, are there any kind of research projects or collaborations that you're really excited about? Any upcoming?
Oh, so we just started. So my group was, every year I was just adding one person in the group. And in the last 4 years, it was like 4 people.
Yeah.
And now it's suddenly 10 people.
Yeah.
So we got a new Science Foundation Ireland grant, and that adds on new PhD students. So there are 3 new PhDs and a postdoc starting in that project.
Yeah.
And we are trying to create this new compositions that will be really amazing.
Yeah.
For different applications in optoelectronics, thermoelectrics, and catalysis. And we have collaborations with Birmingham University and Austria and Belgium. And most of them are actually my friends.
Okay.
So it's actually nice to finally actually have funds to collaborate with them.
Yeah.
And send my students to their place, get them to come here. So that is something I'm really excited. So for the next 4 years, I'm actually really looking forward to really start this project and come to a level that would actually increase my horizons in the nanocrystal community.
Okay. And I suppose you've kind of mentioned it, right? But what keeps you motivated day to day? Like, what makes you want to stay in where you are most?
Coffee.
Exactly. Key to happiness in life.
Me and my Nespresso. No. I don't mean, jokes apart. So motivation actually technically comes from student, right? One part of the job that I really take it really seriously is mentoring.
Okay.
So either it is undergrad students, motivating them to actually take new risk in life, motivating them to actually study chemistry, to actually have a career path in chemistry, and then my research group where I have PhD student, postdoc, and then shaping their career up so that they become the next generation of scientists. And who knows, one of them can get the Nobel Prize. Why not?
Yeah.
So mentoring is something that actually motivates me to come to work mostly.
Yeah.
Because even just talking to them about their science that they're doing and the excitement that they have, or sometimes the stress that I can actually relieve in a way, because I have in my office, I have a tissue box called Only for Wiping Tears. And because there's if you're doing PhD, it's 4 years of commitment, right?
Yeah.
Not every day you're going to just go in the lab and create the best crystals out of it.
Yeah.
Many days are frustrating.
Yeah.
And then if you have personal problems or some professional issues or something, it creates a lot of stress. And I'm happy if I can actually be of any help to actually make them motivated for life. So that itself actually motivates me a lot. And I talk about it like all the time, that mentoring for me, it's like a religion and I take it really seriously.
Yeah.
So it's like these students actually keep me motivated and happy.
And like, do you have any kind of rituals or habits that you do like on a day-to-day? Joe, like you're going into a lab, do you have any kind of specific rituals?
Okay, so I'm actually I'm a big planner person. Unless and until every hour of my life is not planned, I just can't function.
Yeah.
Like even my weekends are planned.
Yeah.
Like every hour. So I'm just too much into like planning it, and some people might find it really boring, but for me it's like what's coming on, because of course like only 20% might actually go as planned. There are 1,500 different things that I overlooked and just came up with
Murphy's
something,
Law,
right?
anything that can go wrong.
Yeah, but at least sticking to a plan just makes me motivated in a way that no, I know what the next hour looks like at least. So planning every day, 8:30 I'll come to work. The first 5 minutes will be like what the day looks like, and then I'll start the day.
Yeah. Okay.
Okay, so if there is anybody listening to this podcast, hopefully there will be at least some people that will want to pursue a career in chemistry or study it in college and then pursue it as a career. Do you have anything that you might say to that person, or any advice you might give them?
Don't be afraid of the subject, right? Because there's something like, even in chemistry and physical chemistry, there's quantum mechanics. And I was always afraid of it.
Yeah.
I unluckily didn't had a very engaging teacher as well. And genuinely, I just lost my hope that I wouldn't be able to do anything because it's just so hard.
Yeah.
I can't really. So I created a barrier for myself that literally no one can actually teach me because it's just so hard. So that is one thing, just I was too afraid. So if you are in the spot where you're actually afraid of a subject, try to just, take it easy and don't be afraid, and let the resources explain it to you.
Yeah.
So if in case I just had a look on quantum mechanics books or talk to someone who is engaging in telling me on it, because I actually studied it after finishing my PhD properly.
Yeah.
Because I work in quantum dots, so I had to.
Yeah.
But at that point, I was just nervous. Like I will just start sweating if someone is saying quantum mechanics, and I actually memorized quantum mechanic questions to go and do in my exam, and that was the worst thing I did for myself. So don't be afraid of the subject. This is one thing that you will do a huge, a very good thing for yourself if you are not afraid of the subject. Just take it as it is and just try to work hard on it, and trust me, you will get it.
Yeah.
Everyone gets it.
Is there any particular kind of opportunities you might advise someone to, I suppose, seek out if chemistry maybe is something they're interested in?
In what context?
And I suppose in the context of wanting to maybe pursue it in college, or just kind of trying to grow their interest in it as a subject, maybe outside of the leaving cert setting, that it's probably been, I suppose, that it's taught to them, and if that kind of makes sense.
In the sense like resources out there?
Yes.
Okay, so, oh my God, there are so many different channels on chemistry as one of the coolest subjects on planet Earth.
Yeah.
So one thing that I really like, if you're doing chemistry in leaving cert, right? And on YouTube as well, there's a lot of chemistry classes, right? Go for it. Some of them are really interactive. Like I personally like Khan Academy a lot.
Yes.
Yeah.
Right. And that actually gives you a proper idea, because sometimes like chemistry is also a lot about looking into the atoms and the molecules in space. And we have a very 2D vision when we actually try to imagine molecules. We don't really see or understand things in 3 dimensions,
Yeah,
or we
yeah.
actually don't imagine them in 3 dimensions. So this kind of interactive websites actually really make it easier to actually understand how chemistry happens in 3 dimension, in my opinion. So go for all these YouTube, like use YouTube for actually studying chemistry more than actually listening to music,
Yeah.
in my opinion. And listen to the guys in the podcast. They have a lot of different chemistry professors, and definitely one of those fields will excite you, because in my opinion, like irrespective of what field you choose,
Yeah.
if you are doing STEM, at the end of the day, you will make a difference.
Yeah.
And not only STEM, like even arts and history as well. If you're committed to into a subject, you will make a difference.
Yeah.
So if you're any point, if you're interested in chemistry, definitely look into all these interactive websites of YouTube, like the different channels of YouTube and different magazines. Like I like CN a lot,
Yeah.
and there are free articles. 5 of them are every month free. So you actually learn a lot from there. In the Nobel Prize website as well.
Yeah.
Every Nobel Prize and the report on why they gave this Nobel Prize itself is actually painted in a very public kind of way.
Okay. Yeah.
So you can actually learn even without having a proper idea of the entire chemistry of it.
Yeah.
You would know the significance of why this was really an important field to tackle.
Yeah.
Yeah.
And books, lessons in chemistry, anyone has learned? It's actually, they have episodes on Apple.
It's a brilliant book.
Yes. One of the best chemistry books. And if in case you really want to learn about chemistry a lot, right? I don't know, last year, there was this Nobel Prize in medicine gone to Kathleen Carrico.
Yes.
So she's this Hungarian-American woman who actually started mRNA vaccines. And that's where it was actually a big contributor in actually making COVID vaccines, right? She has her autobiography out. Oh my God, really read it. Everyone, you just need to read it. The struggles and the persistence of that woman and the whole commitment towards science is just so good.
Yeah.
That in a very bad day, it motivates you for life.
Yes.
She's just brilliant. And if you guys want, like I have a copy in my living room that, so I can give you the copy. I just love her so much.
Yeah.
So they're a brilliant scientist out, and there are many more books, right? And these two are just the current ones that I've been reading, so I kind of remember. But definitely, if you are into science, like definitely read these 2 books. That will give you a nice flavor of how life and science look like.
Okay, so one final question. To all the Leaving Cert students who are currently listening to this podcast, any advice?
Any advice? Have a nice work-life balance. I'm now learning how to have it.
Yeah.
But have a really nice work-life balance. And by which I'm saying that your life and work should be properly balanced, not the one way up, one way down. Do not overdo work and do not overdo enjoy life. Really nice balanced life. So definitely take care of your mental health. That's really important, because that is something that I have seen after COVID is the stress that was there before in people has been technically like multiplied 1,500 times, and people are more stressed.
Yes.
And it was a pandemic, and it's not the last pandemic. There might be more coming, who knows?
Yeah.
But to go through all these things in life, the best thing is to actually, if there is any issue, definitely seek help. Seeking help is the best thing you will do to yourself and to your loved ones. And if you're looking to go for exams, don't be afraid. Be calm and just do the best you can. I'm not very good in motivational speaking. my siblings didn't really took in anything that I spoke to them about or motivated them. But if in case, I'm very passionate about my science, and I'm very passionate about the things I do. So I'm hoping if you are doing Leaving Cert and you get a chance to actually work in science, or to actually work in, and as a professor, as a scientist, just do what you're more passionate about, even if it is medicine or chemistry or mathematics or physics. And life will actually become really easy and you'll enjoy it more.
Yeah.
Yeah.
So, yeah, that's all. Otherwise, there are 1,500 more advices to give.
Yeah.
And, yeah, work on.
Fabulous. Thank you very much.
Thank you so
Yeah.
much for.
Very interesting conversation.
Yeah, I loved it.
Thank you very much for your time.
Thank you.
And if you want to learn more about Shalini and her research, there's going to be links in the description of the podcast for you to do exactly that if you want to read up on her. And yeah.
Don't forget to follow our Instagram and TikTok.
yes, Instagram, TikTok, and yeah, listening on Spotify or wherever else you get your podcasts, on YouTube as well for the video. And yeah, that's it. Thank you very much, everybody.
Thank you.
Thank you so much.